Hello students, welcome back. As you can see, the topic of discussion for today is valency. Now, why valency? Because I have seen that many students face a lot of problems with this particular topic. The purpose of this lecture is to help the students to clear their concepts about valency. Now, this valency, this term is pretty small. It's a very interesting and a very important topic of chemistry, of course. I know this. But since the problems, the confusion remains a lot of times, and most of the times the students face a lot of confusion regarding this term, that what is this actual valency is, or rather how to determine the valency under circumstances, valency of an atom of an element. So for that reason, in order to clear their doubts, in order to clear their concepts, the problems, so this lecture is all about. So let's start with discussing with balance. Okay. As if you follow our or rather my previous videos, every time when I come up with new topics of discussion, I always say that we need to follow the definition or the meaning of the word which we are discussing. First, we need to understand that. So, in simple words, I will definitely allow, as I do, is I will always start with the definition. Now, what is the definition of balancing? I'll start with a very simple definition, the simplest of all, as you may find in different books. The simplest of all definitions, that is the combining capacity of an atom of an element. That's the most simplest definition of balance. And every time I also say that whenever we are writing a definition, we should always give examples. That is also a part of writing definitions. So whenever you're giving a definition, always give examples because that makes the definition complete. Without examples, specifically in science, or whether it's physics or whether it's chemistry or biology, whether it's whatever you're writing, or even if it's geography or it's history or maybe are there any other subjects. So everywhere, whenever you're giving definitions, try to give examples. So here also we are giving example. That is, example is valence of sodium atom is equal to 1 and valence of oxygen atom equals to 2. Now, this gives us a complete definition, but this does not clear what is valence is. So what do we need to do? Let's understand the definition first. We need to understand the definition first. So how we are going to understand the definition? We are going to understand the definition in a total segment, rather as a complete one. That means the definition we read just now, we are not going to rather interpret, or we are not going to understand the definition in a complete or in a total manner. We are going to we're going to break that one up first into segments, and if we break that one into segments, into smaller parts, and if we are able to understand the meaning of those parts, I think the concept or the confusions regarding valency will become more clear. The confusions will be over, and for that reason, and hence, uh, I don't think there will be any confusion regarding that. Okay. Now, let's understand the definition first. Okay. What do we mean by combining capacity? If you remember the definition suggests the combining capacity of an atom of an element. The definition was combining capacity of an atom of an element. So we'll start with the definition of with segments. That's what do you understand by the combining capacity? Okay. The combining capacity. This is what do we mean by combining capacity. In simple words, the ability of an atom to combine with other atoms. right? The ability of an atom to combine with other atoms. And what do we mean by the word to combine? That means to make relationship. I'm just going by the word, or rather, the meaning of the word combine, but the English word itself. Combine is one word you can consider as to make relationship. That's combination, isn't it so? We can write as a or the formation or establishment of a relationship. Or so the ability, capacity means capacity or combining capacity. That means ability of an atom to combine. That means to make relationship with other atoms. So combining capacity, the ability of an atom to combine, that means to make relationship with other atoms. So what is the ability? That we will focus. So that's what we call as combining capacity. What is the ability? Right? So that is, in other words, we can say that with how many other atoms one atom of an element can combine. As we are saying, there's a combining capacity, the ability of an atom. Combining capacity, we're writing the ability of an atom to combine with other atoms. That means to make a relationship with other atoms. That is, with how many other atoms one atom of an element can combine. With how many other atoms the one atom of an element can combine. That means to make a relationship. That means one atom of an element can make relationship with how many other atoms. Okay, that is the explanation or the meaning, the simplest meaning, right? So if combination is not taking place, then valency of an element will not make any sense, or rather does not exist. Isn't it so? Don't you think so? If the combination, understand this very carefully, the combining capacity, that means I said ability of an atom to combine, that means to make relationship with other atoms. If combination is not taking place, so when combination is taking place, then only the concept of valency will exist. That means valency will be there. If combination is not there, then what is the purpose or what valency, or do you think valency will exist? No, definitely not. Valency will not exist. Hence, combination, that means this relationship establishment is very important. One single atom, if it is not making a relationship, if it's alone, then there will be no valency. Only the concept or the existence of valency is there when there will be a establishment of relationship. That means it will combine. If it does not combine, then no valency will be there. Right? So the combination is very important. Okay? Suppose a valency, or I'm giving over here, a valency of a molecule of an element is 0. Why? Now this molecule of an element is 0, there are two interpretations. There are two interpretations. That is, valency of a molecule of an element is 0. That is, valency of a molecule do not have any valency. Always remember this. Valency of a molecule of an element is 0 means if an element is having a molecule, you will never write that the molecule is having any valency. So a molecule of an element, it can be a molecule of hydrogen, it can be a molecule of nitrogen, it can be a molecule of oxygen or any other molecules. Molecules do not have valencies. And hence it's called molecule of an element is always 0. In a general sense, elements are having valency 0. Elements are always having valency 0 because elements are neutral. Why elements are having valency 0? Because elements are always electrically neutral. So elements are not charged up species, elements are neutral species, elements are not having it's not having any bond, or it's not having any, not having any relationship, no combination. It's alone. And hence, as in an overall way, valency of an element is 0. But what about the valency of a molecule? Molecules do not have any valencies, of course. Also. So valency of a molecule, that also does not exist. Then valency of an atom in a molecule of a compound cannot be 0. So molecule of an element does not have any valency. Valency of an atom in a molecule of a compound cannot be zero. This cannot be zero. But there is a but. Valency of an atom in a molecule of an element that also can be zero, cannot be zero. Okay? Valency of an atom of an element, valency of an atom in a molecule of an element can be zero, cannot be zero. So, for example, if the valency of an atom in a molecule we are considering that's an inert gas, so that is itself a molecule, and that is itself so that it's the lowest, the simplest of the existence of inert gases. That is basically the smallest part of existence. That's basically a molecule, and that molecule is itself on one side it's an atom, on another side it's a molecule. For example, He. So we do not write He2 because He is having independent existence. So it's a molecule as well as it's an atom. So when it's a state that it's a molecule as well as an atom in the same form, so it cannot be it's having zero. It's an atom. It's a molecule also. So it's a zero. Similarly, valency of an atom in a molecule of an element. Another example that is oxygen. Oxygen exists in the form O2. Fluorine exists in the form F2. But fluorine, this F2, it's a molecule. But so fluorine F2, this molecule is having valency 0. But fluorine, this F atom, is having valency 1 within the molecule itself. It's an atom within the same molecule. And that's an element, of course. It's not a compound, it's an element. And having valency 1. So, valency of a molecule of an element is 0. But this valency of a molecule is 0. The valency of an atom in a molecule of a compound, it cannot be 0. But the valency of an atom in a molecule of an element, that can be 0, that cannot be 0. Alright? Now let's do it, or let's go on to move on to the example. First example is NaCl, sodium chloride. Now, in the simplest way, sodium is having, Na is having an ability to combine with one chlorine atom. I'm going for the definition. Just understand this. The first definition we gave out, or rather I gave out about valency, regarding valency, and just going by the definition itself. The sodium is having an ability to combine with one chlorine atom. Chlorine is having an ability to combine with one sodium atom. Okay? So sodium is having an ability to combine with one chlorine atom. Chlorine is having an ability to combine with one sodium atom. Let's move on to another example. That is NH3. That's ammonia, we know that. So nitrogen atom is having an ability to combine with 3 hydrogen atoms. N atom. N is nitrogen over here. So nitrogen atom is having an ability to combine with 3 hydrogen atoms, as we can see over here. Similarly, hydrogen, from the perspective of hydrogen, understand this, there are 3 hydrogen atoms. Now from the perspective of each hydrogen atom, it is combining with 1 nitrogen atom. Right? Yes or no? Hydrogen atom, from the perspective, there are 3 hydrogen atoms present, and from the perspective of 1 hydrogen atom, each one, from the one individual 1 hydrogen atom, it is having an ability to combine with 1 nitrogen atom. So it's visualizing, or it's looking as if that it is actually combining with only 1 nitrogen atom. So what does it conclude? The conclusion is the valency of nitrogen is 3. The valency of hydrogen is 1. As of the previous example we discussed, that is with sodium chloride, the sodium combined with 1 chlorine atom, so that's the valence of sodium is 1, And from the perspective of chlorine, which combined with one sodium atom, the valency of chlorine is also 1. Okay. Now over here, this gives us a very a rather first discuss another very important question. What is the intention of an atom for this combination? That's a very important question. It's combining. But what is the intention of an atom for this combination? Why it will combine? It's just we are following as a combining capacity, its ability to form a relationship. The question comes with why it will participate or why it will undergo to form a relationship. Right? That's a very important question. To participate or to form bonds. The answer is to participate in bond formation or to participate or to make bonds with others. It means relationship. Bonds means relationship. It's a one way of explaining that bonds or meaning of bonds. That's relationship. There's another way of explaining things that's apart from bonds. That is, it's a deal. Okay. Well, so we'll focus on the deal to a separate part. That is the first thing, the simplest one. It's bonds. To participate or to form bonds. Now, to explain this, that is, so the ability or capacity of an atom to combine with another atom depends on the number of bonds an atom has made with another atom. So repeat, the ability or capacity of an atom to combine with another atom depends on the number of bonds an atom has made with another atom. So that's what we call as a combining capacity. That means the ability or the capacity of an atom to combine, that means to form a relationship with other atoms. That means the number of bonds. Bonds we are having with another atom. We can have a similar sort of relationship with one. We can have a name. For example, we can have we are having friendship. But the relationship is a friendship. But you can have such relationship with multiple people. You can have friendship. You can have multiple friends. So you are the one which is common, but you are having multiple friends. So with one-on-one, the relationship it's basically that two people are involved in a relationship, and that relationship it's basically having a name that's what we call as a friendship. But how many relationships you are having? How many? That's relationship. How many bonds you are having? You can have multiple relationships with multiple bonds with other atoms. That means with other friends. We're having other people. We're having multiple relations, multiple bonds. So the ability. So you know that some people are having less friends. Some people are having many friends. Some are having 10. Some are having 100. So it depends upon your ability to make friends. That means to make bonds with others. So that's your ability. So similarly, an atom is also having an ability. All atoms do not have the same capacity to make bonds with others. So here lies that's what you call, if you're having multiple friends, that means you're going to have 100. That means your valency is 100. Some are having 5, so their valency is 5. Similarly, an atom who is combining in a way that's having a relationship that's about forming bonds, that's number of bonds, there's only 1, it's having valency 1. If another atom is making valency, or rather making 3 bonds, that means valency 3. Right? So from this perspective, we'll once again revisit our examples. Okay? The example was sodium chloride. So sodium is making 1 bond with chlorine atom. Chlorine is making 1 bond with sodium atom. That means the valency of sodium is once again 1 from this perspective, and the valency of chlorine is 1 again from visualizing from this perspective. Moving on to another example, that is ammonia. So nitrogen, this one, N atom is making 3 bonds with 3 bonds with 3 hydrogen atoms. So the valency of nitrogen becomes 3. Now similarly, the hydrogen atom is making 1 bond with 1 nitrogen atom. Understand this, from the perspective of nitrogen, Nitrogen is visualizing that it's making 3 bonds with 3 hydrogen atoms. But what about hydrogen? Hydrogen, from the perspective of hydrogen atom, it's making 1 bond with 1 nitrogen atom. It's not having multiple of 3, 2, 3, 4, 5 nitrogen atoms. It's having 1 nitrogen atom, and hence it's having 1 bond. Whether do not consider there are three hydrogen atoms are making 3 bonds. But from the perspective of each hydrogen atom, it's making 1 bond with 1 nitrogen atom. But from the perspective of nitrogen atom, it's making 3 bonds. So nitrogen, it's visualizing that I'm making 3 bonds. 3 people, there were 3 hydrogen atoms, so there I'm making 3 bonds. And hence the valency, it's my capacity to make 3 bonds at a time. And hence the valency of nitrogen is 3, and the valency of hydrogen is 1. Concluding, based on the previous examples, the valency of sodium atom is 1, this NaCl is 1, and chlorine is 1. And similarly, valency of N atom is nitrogen in ammonia, it's 3, and hydrogen is 1. Now, from this point of view, once again, we will ask another question. That's a very primary or very primitive, or maybe it's a very general or genuine question we may ask, or a very fundamental thing. That is, which fundamental parameter governs the existence of a bond? That's a very important question. Which fundamental parameter governs the existence of a bond? And the answer is drifting of electrons. So electrons are the fundamental parameter which governs the existence of a bond. That is, drifting of electrons. If electrons exchange, transfer, or sharing, whatever. So if electron exchange takes place, electron drifting occurs, moving of electrons between 2 atoms takes place, then only the existence of bond is possible. Whether it is within a particular molecule of a same element, or whether it's a molecule of compound where atoms of different elements are present. Only drifting of electrons governs or drives to the existence of bond formation. Right? So, a couple of electrons are responsible for 1 bond formation. A couple of electrons are responsible for 1 bond formation. So this is the minimum number of electrons responsible, and that's the maximum number of electrons responsible. Maximum number of electrons responsible for 1 bond formation, that's 2. The minimum number of electrons responsible for 1 bond formation, that's also 2. Now the number of bonds, rather multiple electrons can participate in bond formation. That means the number of bonds can be more. There can be rather 2, 3, 4, 5, 6 or multiple bonds. But that does not mean that 6 or 7 or 8 electrons are responsible for 1 bond formation. For 1 bond, single bond, one bond formation, only 2 electrons are responsible. And for 1 bond formation, the maximum of the 2 electrons are responsible. Now there can be multiple bonds which will force other electrons or multiple electrons to get incorporated, or rather to participate in this bond formation. But there will be multiple bonds. Okay? So increase in the number of electrons combining increases the number of bond formation. Increase in number of electrons combining increases the number of bond formation. Okay? Let us analyze this with an example. So number of bonds within a molecule signify the valency of an atom within the molecule. Number of bonds within a molecule signify the valency of an atom within a molecule. For example, calcium oxide. The calcium is making 2 bonds with oxygen atom, and oxygen atom is also making 2 bonds. So you can see calcium is making 2 bonds. The structure is given over here. And oxygen is also making 2 bonds. Thus, valency of calcium is 2 and oxygen is also 2. Calcium is making 2 bonds. Oxygen atom is also making 2 bonds. So valency of calcium in calcium oxide, it's 2. And oxygen atom is also, that is also 2. Moving on to another example. We'll switch over to another example. That is PCl5, phosphorus pentachloride. Phosphorus is making 5 bonds and 5 chlorine atoms are making 1 bond each with phosphorus. Once again, if you remember that example from earlier, from the perspective of phosphorus, phosphorus can see is visualizing that it's making 5 bonds at the same time. It is having the capacity to make its 5 bonds at the same time. What's the perspective of chlorine? Chlorine, from its point of view, chlorine is visualizing that it's making, there are 5 chlorine atoms, but from each chlorine atom, it is visualizing that it's making 1 bond with each phosphorus atom, and each means 1 phosphorus atom is present. Only over there. Over here, it's 1 phosphorus atom is present. And from the perspective of each phosphorus atom, from the perspective of each chlorine atom, it's making 1 bond with 1 phosphorus. You can see the structure over here. From 1 bond, chlorine, from each chlorine atom, it's visualized there is only 1 phosphorus. It's making bond with 1 phosphorus only. So chlorine is from chlorine side, it's making 1 bond. But what about phosphorus? It's making 5 bonds at the same time. Chlorine is making just 1. Just 1. And hence, the valency of phosphorus is 5 and chlorine is 1. And so, okay. Moving on to another example now. That we are having H2S and SO2. In H2S, each hydrogen makes 1 bond with sulfur, while sulfur makes 2 bonds with hydrogen at the same time. Each hydrogen makes 1 bond with sulfur, while sulfur makes 2 bonds at the same time. And hence, the valency of hydrogen is 1 and sulfur is 2. In SO2, each oxygen atom makes 2 bonds with sulfur, while sulfur makes 4 bonds at a time. From each oxygen atom, oxygen is making 2 bonds with sulfur, but sulfur at the same time is making 4 bonds with 2 oxygen atoms present. And thus, the valency of oxygen is 2 and sulfur is 4. Now there is another definition of valency. That is in terms of electrons, and that is the number of electrons donated, accepted, or shared by the valence shell of a neutral atom of an element in order to attain the nearest inert gas configuration for stability. This definition is in terms of electrons. The number of electrons donated, accepted, or shared by the valence shell of a neutral atom of an element in order to attain the nearest inert gas configuration for stability. Let's visit another example, or rather revisit the previous examples. Phosphorus pentachloride. This is a structure. And over here, the electrons participation, you can see there's a cross and there is 1 dot. So the dots belong to chlorine and the cross belongs to phosphorus. So from there you can see that from the chlorine side only 1 electron is participating. From chlorine, each chlorine atom 1 electron is participating. But what about phosphorus? All the 5 electrons. Phosphorus, the valence shell is having 5 electrons, and all the 5 electrons have already participated in bond formation. So phosphorus shares 5 electrons and chlorine shares 1, and thus the valency of phosphorus and PCl5 is 5 and chlorine is 1. So another example, that is previous one. Number of electrons participating from the side of calcium is 2, and that of oxygen is also 2. So if similarly, I will explain the same previous thing in terms of the electron concept. That is, From calcium, if you remember, I'm giving away the valence structure over here, but still it's a general bond structure. The valence shell of calcium is having 2 electrons, and the valence shell of oxygen is having 6 electrons. From the perspective, from the perspective of calcium and oxygen, the calcium, all the 2 electrons have participated in bond formation, and over here, basically, there's a donation. Okay, over here, it's not in the previous PCl5. There happens a participation of the sharing of electrons, but over here it's an ionic compound, so it's a donation of electrons take place, and thus calcium donates 2 electrons and oxygen accepts 2 electrons. So if calcium donates 2 electrons, what happens? Calcium attains the nearest inert gas configuration of argon, and oxygen, after accepting those 2 electrons, attains the nearest inert gas configuration of neon, and thus making once again the valency of calcium is 2 and oxygen is also 2. Okay, so this is all about valency. This is all about the basics of valency. So I've tried to explain the valency. I hope you have understood, what is valency, how to determine valency. There's just the fundamentals, or I've tried from my side as an attempt to explain valency in a very, very simple manner, in a very simplest of the form, by giving examples and or other in a different way, by explaining each and every part and each and every meaning of the definitions. So this is basically valency. I hope the concepts have been clear, doubts are clear. Still, after going or listening to this lecture, if you have still any doubt, you're free to contact me or ask me questions. The contact details are given over here. The mail ID is given. You're free to ask me questions, anyone. You're free to contact me anytime. So that's all for today's lecture, today's class with Valency. We'll catch you out with another more other topics which will help you out in chemistry subject. Till then, thank you so much. God bless you. Stay safe and take a very good care of yourself. Thank you.